Hello, good day. So I'm going to give you a walkthrough of how are you going to solve your OS Laboratory 2, exploring the file systems and utilities. So I hope you downloaded the file. So if I may show you, it would be a zip file. So all you need to do is to extract first this one. If you haven't yet downloaded your WinRAR, then please go and download and install it to your system so that you'll be able to see the content of the CIF folder that is there for this exercise too. So I have already extracted it. So if you're going to check the content, you will have two folders and you have the Word document, which is the one that I have on the background. So let's open it. So I have opened it anyway. So this one. All right. So in this laboratory, we will explore the file system and we're going to use one particular command, which is the du or the usage. So it is a standard Unix program used to report file space allocation for a given directory. Apart from that, we are going to explore the file usage. This is written by my colleague in C++, and it will report some file usage also for a given directory. And in this exercise, we'll be calculating internal fragmentation given different cluster sizes. So if you will recall, in our discussion in our class, that a standard hard disk, it has a sector of 512 bytes. And a cluster or a block is the smallest amount of disk space that could be allocated to hold a file, and usually larger than 512 bytes. And I hope I mentioned with you that for Windows, it's getting or using by default 4096, and for Unix file system, the cluster size is 1024 bytes. So according to the instruction, we're going to unzip all the files and we're going to copy those folders to your C drive. So let's navigate there. So you have your file USAID and tester here. So all you need to do is to copy this one, go to your C drive, then paste it here. All right, so we have our tester and the file usage there. Then it says here we will record our explanation about each of the command and provide a record. Each of the command will provide a record of the cluster count in each of the runs. So this is what that one is referring to. So we have several commands here. You will be providing the explanation here, and you will report the cluster count, total cluster count in each of the run that you have here. All right. So, but before we do that, we will have to open our Cygwin and we will issue a CD to tester. Okay. So I have opened my terminal here. So I will issue a CD, C, then tester. Press enter. All right. So after I finish changing the directory, I am now ready to go to question number one. So question number one, so it's there. So du, okay, press enter. And on the last row here, it will give you the total cluster count. So it's 35,889. So 35,889 is written in there. So the explanation here is, of course, not found here in the Cygwin. You have to research. You could use the internet for you to be able to get the explanation of what this DU is doing. So go and research in the internet, use Google to get this one. But I suggest that you have to rephrase it so that you will not be plagiarized. Okay. So let's proceed then to number two. Let's do that. So we have du minus h. Press enter. Then you have this result. So what you're going to do is to put the cluster counts 36M in here. Okay, so maybe I could just put this one side by side so that I will not keep moving it. So here, so you have your 36M. Then, okay, provide a short explanation of what this command is doing. All right, so I give you one more. So number three, let's do that. So du minus h, then press enter. So I have this as the cluster count. So you will put here 35,889. Okay, and you will provide the explanation in here. All right, so you complete the table by doing all the commands here. And okay, after you finish the total cluster count, you'll have to put the explanation on this part of the table. All right, I hope okay, part one is clear. So we will go to part two if you don't have any questions here. Okay, so question number or part number two is about internal fragmentation. Okay, so answer the question about the directory C tester. Record your answer in the column provided. So question number one, what is the total size of tester in bytes? Okay, so for you to be able to get this one, I believe the command that you're going to use will be this one. Okay, so if you issue, that's question number seven, du, okay, minus b, sorry, should be here, the other side, okay, here. So du minus b, so we'll have this number as, oops, this number as the answer for that. So I'll just copy and paste it there. Pastes. Okay, so that is the total size in bytes of tester. Okay, so now, so what is the cluster count if the cluster size is 512? Okay, so to answer the succeeding question, I will show you one file here. Okay, so as discussed, a hard disk is having 512 bytes by default as the cluster size. Unix systems have 1024 bytes and Windows having 4096 bytes. So internal fragmentation is defined when a file does not entirely fill a series of clusters. Okay, so maybe we could just switch back to your PowerPoint presentation. So yeah, so this is what I told just now. So remember, okay, your cluster are in series. So this may be your cluster one, 2, 3, 4, 5. And if there is an incoming file and it's only fitted to the first 5 cluster, and you see here that it touched cluster number 5, but it's did not entirely use cluster number 5. So there is a portion there in red that is actually wasted. So that is not utilized by some other programs already. So this is a waste. So this is actually called an internal fragmentation. All right, so let's look at an example. So in a Unix environment, say there are 3,000 bytes to be saved on the disks. So how many clusters are needed? So that's the first question. So we will need to define, actually calculate how many clusters will be needed for us to load this 3000 bytes of a file, and what is the internal fragmentation, or how much is the internal fragmentation. Okay, so given from the question that we have 3000 bytes, and the environment that we're going to look into will be the Unix. And Unix, as been said, is having a cluster size of 1024. So the question will be for this one, you have to identify how many 1024 are you going to use for you to be able to fit in this 3000 bytes. Okay, so in a simple analogy, so 1024, okay, will be not enough for this one, right? So perhaps you'll need another 1024 for you to be able to fit in this value. But again, there's still an excess. So the excess, let's calculate. So so 1024. So 1024 times 2. So this is only 2048. So you are not able to cover yet the 3000 bytes, right? So what you will do is to put another 1024 so that you will have to accommodate this 3000 bytes. So if I'm going to go back to my calculator, so now I have 1024 times 3. Okay, so basically I have 372, right? 3072, sorry. 3072 as the total, okay, that I'll be using. However, the last 1024, I will not be able to use it, right? I will be having an excess of 72, okay, because I am only going to load the 3000. Okay, so the question on how many clusters are needed. So you will have to determine how many 1024 that were used. So for the required cluster, okay, you will be having 3. Then how much is the internal fragmentation? So internal fragmentation will be that 3072 minus 3000. So you have 72 as the internal fragmentation. Okay, so that applies to here. So basically the same. So the cluster size that is mentioned for number 2 is 512. So you will use that to identify how many clusters are you going to use if this is the number of bytes that is given. Then after you calculated the number of clusters, what you're going to do is to calculate the internal fragmentation, okay, based on the values that you have calculated in item 2. Okay, so let's have another example. Okay, so in Windows environment, so this is Windows environment. By default, the cluster size there is 4096. Say there are 5000 bytes to be saved on the disks. So how many clusters are needed, and how much is the internal fragmentation? So again, we know that Windows is 4096. So with that 5000, so we will need 14096. Okay, but this is not enough. So there's still a file there that will be left. So you need another 4096, okay, for you to be able to accommodate that 5000. However, that 4096, a total of 4096 times 2. So you have 8192. So 8192 as the total. Okay, so what's the excess of this one in here? So you'll have to minus it with 5,000. So that's equal to, so minus 5,000. So you'll get 3192. 3192. So it's very obvious that the cluster, the required cluster that you will need will be 2, and the internal fragmentation is basically this one, right? Okay, so we'll have there. Okay, so this is the internal fragmentation. Okay, so the unit is bytes. Okay, also here, bytes. All right, so that's for question number 2, 3. Okay, question number 4 and 5, and question number 6 and 7. Okay, so if you don't understand yet, I think 11, question number 11, okay, will help you out to validate the calculations that you have here. Okay, so again, question 11, this will give you the, uh, let's go back here. This will give you this one, okay, the required cluster size. So you may would like to validate your answer, okay, your answer for question number 2, question number 4, and question number 6, okay, with your command here. So you just change the size here to 512, okay, change the size of this one to 1024, then change the size there to 4096. Okay, so your answer should be the same as what we have in question 11 after you execute question number 11. All right, so we are now in part C. So we're going to explore the file usage command. So according to the instruction, we're going to open our command prompt console in Windows. So to open it, so all you need to do is to type cmd here, then press enter. All right, so I'll just put it on the side. So we have it here. Okay, so according to the instruction, we're going to change the directory to file usage. So we'll issue a cdc, okay, file usage. Okay, press enter. Then we're now going to execute the commands here. So let's start with number 1. So file usage, press enter. Okay, so we have the same here as what is written in our console. So we're going to copy this value. So we could right click, oops. We could copy, then put it there. So it's already provided anyway. Then you're going to complete the table here. All right. So let's go to question number 2. So you will issue file usage C, then tester, press enter. So you have this value, control C, then I'll put here control V. All right, so one last time, one last run. So question number 3. So file usage minus R C tester. Press enter. So you'll have this value, control C, control V, then you're going to provide your explanation here. All right, so once you finish all these things, so all you need to do is to save it correctly. Then what you're going to do is to submit the Word document in our FOL. All right, so hope everything is clear. So I'll be waiting for your answers for laboratory number 2. Ciao. See you. Bye.